Good afternoon, CC3. It's Miss Angel here with your instruction for today. So thank you to those of you who have joined the Google Classroom. We will now be doing all of our communication through that medium. Without further ado, let's get started. Today's IXL code is DC2. So again, when you log into your IXL, you're going to go to where it says search topics and skills and DC2, complete a table and graph of a linear function. So this is very similar to what we were doing last week. Last week we were filling in tables for functions and graphing points. Today we're putting all of it together. So here's a possible example. You're going to be given a function with y and x. You're going to be asked to input values of x into the function to output values of y. Now, while you're doing this, it is helpful to have a piece of paper out in front of you so that you can actually show your work and keep your work organized. So if I show you really quick what that would look like, that might mean that over here, I have my function y equals 2x. And then over here, I just put a quick table showing the values of x that I was asked to input, which in this case was 0, 3, and 5. Now, you might be able to do this one more mentally because all it's asking us to do is multiply x by 2, but it will get more complex as you go along. So if I input here, 2 times 0 is 0. So when x is 0, y is 0. 2 times plug in 3 is 6, and 2 times 5 is 10. Now, the reason why this is called a function is it's because it's describing how x and y are related. That means every time you look at the y, it should be 2 times the x. 0 is 2 times 0, 6 is 2 times 3, 10 is 2 times 5. Now, that's only the first part of what you'll be asked to do. The second part of this, after you plug them into the table, is you will be asked to select the points on the graph. Now, here's also the difference. Last week, you would have 3 points in your graph. This week, something different is going to happen. Let's start with our first point, 0, 0. That's just the point at the origin, x is 0 and y is 0. Now, as I move my cursor around, what is that? It's going to start automatically forming a line. Now, that line will form once I place a second point. So where do I place the second point? Well, pick the next point that you found, 3, 6. Coming over here, I'm going to 3 for x, up to 6 for y, and I'm placing my second point. Now, there's no need to place a third point because what ends up happening is it ends up forming what's called a line. Now, why does this line form? Well, lines represent all possible solutions to an equation, meaning any point on this line is a solution to y equals 2x. So instead of plotting the point 5, 10, you're going to check the point 5, 10 and see if it's on your line. If it's not on your line, that means that you did that point wrong. So let's see. Going over to 5, tracing it up to 10. This is the point 5, 10. Is that point also on our line? Yes. That's how I know that all 3 points are true because all 3 points are on the same solution line. After I click submit, it gives me a new one to do. So let's try this one here. This one's a little bit more complicated. So if you want to write it down on your paper, you have y equals 2x plus 3, and you're plugging in 4 points this time. So again, you on your paper, you might want to write out the function, set up your table. So this is what your paper might look like. So again, this is pretty straightforward. I'm just multiplying by 2 and then adding 3. So let's try it out. 2 times 0 is 0, plus 3 is 3. On to the next one. 2 times 1 is 2, plus 3 is 5. Now, I'm able to do these mentally, but you might have to write them all out, and that's totally fine. 2 times 2 is 4, plus 3 is 7. And 2 times 3 is 6, plus 3 is 8. All right, so my answers are 3, 5, 7, and 8. So I'm going to pop back over to IXL, 3, 5, 7, and 8. Let's see what happens. So now I'm going to graph my solution line. Starting at 0, 3, And then my next point is 1, 5. Now my solution line has appeared. Now don't just like go on to the next one. This is where you have to imagine that Mr. Adams and I are sitting there with you, asking you to check your work. We're gonna check and see if 2, 7 and 3, 8 are also on that line. Let's see, 2, 7, yes, check, that's on the line. 3, 8, 3, 3, 8 is right here, but that's not on the line. So let me go back to my work and see if I can figure out where I went wrong. 2 times 3 is 6, plus 3 is, wait a minute, 6 plus 3 is an 8, 6 plus 3 is 9. So I made a mistake there. That should be 9, not 8, which I think some of you maybe knew. Let's take a look. So let's change this to 9. So now when I check, is 3, 9 on my line? Yes, it is. So it is so important to check all of your points. Just because it only takes 2 points to make a line doesn't mean that you shouldn't check the other points. Click submit, and we're good to go. I'm going to go ahead and jump a level here because we've already done one kind of like this. And let's see what we come to. You know what, even this I feel like is pretty basic. This just brings you to 5 points. So we're going to jump another level here. And this has to do with subtraction. Yeah, we can go ahead and do this one next. Go ahead and copy this one down and give it a shot. All right, so I've gone ahead and written this one down and we'll give it a shot. So plugging in -7, I'm gonna show my work this time just so that you kind of see what I'm thinking about. When I plug in -7, that means I'm figuring out y is -7 minus 3. So -7 minus 3 is -10. So there's my first set of points, -7 and -10. Now I'm gonna plug in 1. So that would be y is 1 minus 3, which I know is -2. And then my third point, which is 2, y equals 2 minus 3, which is -1. So I think the answers are -10, -2, and -1. The only way to be sure is to actually graph the points and see if they're all on the same line. Oh, this is interesting. I didn't actually notice this. When you get to this point, it looks like you went from just being in the first quadrant here to now an entire graph. It's a good thing that we practiced that last week. So we have -10, -2, and -1. So let's start with graphing the point -7, -10. So starting at 0, 0, I go all the way to -7 and then down to -10. And that's my first point, -7, -10. Now, technically, it doesn't matter which of these points you use next. I'm still just like, I like using the next point. Just, I don't know. It just is something I like to do. So I'm going to start by going to 1, -2. So now my 2 points on my line are -7, -10. Yep, is that correct? And 1, -2. Awesome. Do I just move on? No, you always check the third point. So the third point is 2, -1. Is it on my line? Let's see, go to 2, -1. Is that point on my line? Yes, it is. That's how I know I did my math correctly. Click submit, and we've got it. All right, I'm going to find another example for us to go over here. Yep, let's try this one. This one is going to have us doing a little bit of work with positives and negatives. So if you're following along, go ahead and pause the video now to try this one on your own. If you're doing something on a piece of paper, make sure, you're trying to fix my easel, make sure that you are writing out both the function and setting up a table of values. So we're going to write this one out here. Oops, there we go. So it looks like our function is y equals 8x plus 30. And our values of x are -5, -4, and -3. Let's see how we do this one. So I'm going to write this one out because the larger the numbers get, the more it's better to actually write out your work so you can keep track of making mistakes and things like that. Let's start by plugging in -5. So that means y equals 8 times -5 plus 30. 8 times -5. Well, 8 times +5 is 40. So I know 8 times negative 5 is negative 40. So that means y equals negative 40 plus 30. Now, some of us struggle with this. And what I have found that helps, and this is something that you can either use or not use, but what I do that helps is I actually like to change the way this looks. I know that adding a negative is equivalent to subtracting. So in my head, which is why I'm going to do a little bubble here, this is what happens in my head. I don't think of it as negative 40 plus 30. I think of it as 30 minus 40, because adding a negative is equivalent to subtracting a positive. And that just, to me, is easier math to do than negative 40 plus 30. Either way, 30 minus 40 or negative 40 plus 30 is negative 10. So I got my first one. All right, I'm going to go ahead and plug in the second one now, negative 4. So that's y equals 8 times negative 4 plus 30. 8 times 4 is 32. So 8 times negative 4 is negative 32 plus 30. Again, I don't like doing negatives plus positives. So in my mind, I'm thinking, you know what? Adding a negative, that's the same thing as 30 minus 32. That just helps me. So that means y is negative 2. Last one, negative 3. So y equals 8 times negative 3 plus 30. That's negative 24 plus 30. Again, I'm thinking of that as, put it over here. In my mind, I'm thinking 30 minus 24, because adding a negative equivalent to subtracting a positive, which I know is 6. So if my math is correct, my answers are negative 10, negative 2, and 6. There's only one way to find out. We're going to pop over back to IXL and plug in those numbers. So I got negative 10, negative 2, and 6. Let's see what happens. I start by plotting my first point, negative 5, negative 10. This time, I'm going to plot that last point instead, and then I'm going to check the middle point. Instead of going straight to negative 4, negative 2, I'm going to go to negative 3, 6. Now, there are my 2 points. They're pretty far away. All I have to do is see if negative 4, negative 2 is on my line. Let's see. Negative 4, negative, negative 4, negative 2 is not on my line, which means I made a mistake. And I'm going to be honest with you, I wasn't planning on making a mistake on this one. Let's see if we can go back and figure out where I went wrong. Let's see. Negative 5 times 8 is negative 40, plus 30 is negative 10. I feel good about that. Negative 4 times 8 is negative 32, plus 30 is negative 2. I feel good about that. I feel good about all of this. So why didn't it work? I'm actually not even sure. This isn't even me joking around here. Negative 10, negative 2, and 6. 8x plus 30. Negative. Oh, I know what I did wrong. Oh my gosh, this is so embarrassing. But hey, it happens live, and so you know that I didn't make this up. Look at where I plotted this first point. That is not the point negative 5, 10. That is the point negative 4, 10, palm to face. So you know what? Mistakes happen. I'm just going to fully start over. Negative 5, negative 10, negative 5, negative 10. All right, that's better. And negative 3, 6, negative 3, 6. Okay, let's see. Negative 4, 2 is now on the line. So I know I did it right. Whew. My goodness, I started sweating there a little bit. I really made that mistake by accident. I didn't even mean to. All righty, we're gonna jump another level here. And what? Okay, this is a weird one. What is weird about this function? There's no x in it. So like, how are we supposed to plug in x's when there are no x's? Can I tell you something? True story. Algebra 1 students struggle with this daily. Like, this is one of the toughest concepts for them to grasp, because it's like painfully obvious and painfully weird. So think about what this is actually telling you. The function says y equals 8. It's really actually trying to help you out here. It's telling you it doesn't matter what x is. Guess what? Y equals 8. So that means when x is -10, what do you think y equals? 8. When x is -8, what does y equal? 8. When x is 0, what's y equal? 8. When x is 2, y is 8. When x is 6, y is 8. It's this weird concept, but because there's no output, all we know is that no matter what, y equals 8. So coming over to our graph, we go to -10, 8. How about -8, 8? And then a horizontal line appears. That's because every point has a y value of 8. Let's double check. 0, 8 on our graph. 2, 8 on our graph. 6, 8 on our graph. This is a weird one, but there you have it. All right, I'm going to jump one last level here just to make you see what's coming up. You're going to have to deal with some negatives and positives, and you're going to eventually have to deal with, hopefully, if it pops up, there should be a fraction question. Eventually, maybe not. Well, I thought there was a fraction example. Let me see if I can find a fraction example for you guys. Aha, I have found one. Okay, this will be the last example that we do together. Our function is y equals 1/2 x plus 1. So you will have to deal with some fractions here, which is good because fractions are here to stay. You must have a good solid foundation with fractions to go into Algebra 1. So our function is 1/2 x plus 1. And we are plugging in -10, -6, 4, 8, and 10. So if you want to pause this video and try it on your own, go ahead and do so now. And here we go. So the nice part about this is that taking 1/2 of a number is the same thing as dividing by 2. And looking ahead, all of our inputs are even, which means we're not going to have to deal with any fractions, which is a good thing for most of you. So here we go. I'm going to do this kind of I'm going to more explain my thinking rather than write my thinking. So when I plug in -10, what's half of -10? -5. So I know when I plug in -10, my function becomes -5 plus 1 because half of -10 is -5. -5 plus 1 is -4. So my first output is -4. Plug in -6. What's half of -6? -3. So when I plug in -6, I get -3 plus 1, which is the same thing as 1 minus 3, which is -2. Let's plug in 4. What's half of 4? Half of 4 is 2. So that means my function is 2 plus 1. Hopefully we get that one right. It's 3. Hopefully I got that one right and I'm not making more mistakes. Plug in 8. Half of 8 is 4. 4 plus 1 is 5. And that leaves us with our final question. Let me grab another color here. Our final input is 10. Half of 10 is 5. Plus 1 is 6. So if my calculations are correct, our points are -10, -4, -6, -2, 4, 3, 8, 5, 10, 6. Only one way to find out. Let's see here. All right, when I got -10, I plugged in -10, I got -4. I plugged in -6, I got -2. I plugged in 4 and got 3. I plugged in 8 and got 5. I plugged in 10 and got 6. So let's see here. I'm going to start by graphing the point -10, -4. Now, to avoid embarrassment, I'm going to make sure I don't do this wrong. -10. Okay, we're good. I'm just going to plot the next point, which was -6, -2, and my solution line formed. So let's see. Because it only took me 2 points to plot the line, I'm going to check all 3 of these. Let's start with 4, 3. 4, 3 is on my line. Okay, that's good news. What about 8, 5? 8, 5, also on my line. Good news. Last one, 10, 6 on my line. I know that I did my math correctly and I graphed my graph correctly. Thank goodness. All right, that'll take you to a score of 85, which is mastery. And at that point, you can stop. However, some of you have been attempting some work on your own, or some going above and beyond and trying to get 100. So at some point, you'll reach the challenge, which will lead you to a function without a table. What are we supposed to do here? Here's the deal. If you're given a function without a table, it basically telling you, make your own table, pick numbers that you want to plug in, put them into your function, and see if they work. So just for funsies, let's go ahead and look at this one, and this will be our last example. So our function here is y equals, and it's a fraction and it's a negative. It's like I planned it, but I really didn't. Negative 1/2 x plus 8. Now there is no table, which means we get to pick a table. Now when you're doing this, technically it only takes 2 points to make a line. But I always say do 3 so that you can graph with 2 and check with 1. So if I'm going to be multiplying by negative 1/2, that probably means I should choose even numbers. So let's say I'm going to plug in 4, 2, and 0. 0 is a nice one to plug in because 0 times anything is 0. You'll learn that trick when you get to algebra 1. Okay, here we go. Let's plug in negative 1/2 of 4 is negative 2. Negative 2 plus 8, well, that's the same thing. In my head, I think of that as 8 minus 2, which is 6. Do I believe that? Yeah, I believe that. Let's try the next one. Negative 1/2 of 2 is negative 1 plus 8, which in my mind, I think of that as 8 minus 1, which is 7. Now, at this point, you have enough to graph, but I always like to do a third point because then it just helps me check my work. Now, I'm not going to write out my thinking for this one. I'm just going to explain it. 0 times anything is 0. Doesn't matter if it's a fraction, a whole number, a decimal, or whatever. It doesn't matter. Negative 1/2 times 0 is 0. 0 plus 8 is 8. So that gives me my 3 inputs and my 3 outputs. Now, again, you might notice there is no table here. So I'm just going to have to go based off of what I did here. See if I can make myself a little bigger. There we go. So my points were 4, 6, and 2, 7. And then the third point that I checked was 0, 8. Looks like those 3 points are on the line. I click submit and bada bing, bada boom. All right, awesome CC3 people. That is your IXL code for today. Remember, goal is 75. 75 is passing, 85 is mastery. So, I mean, I guess 75 is kind of the goal, but really your goal is always mastery. And then for those of you who want that added challenge, going 90 and above, you will have to make your own input-output table. Tomorrow we will be having a Zoom live meeting with Mr. Adam and myself to be able to check in with you and see how you're doing. Thank you again for all the work that you're putting in. I know that this is a little bit tough on all of us, but we're very proud of you. We miss all of your beautiful faces and we hope you're doing awesome. Have a great rest of your day.